Hi boys and girls, this is Mrs. Twisdale. I've combined lessons 13.3 and 13.4 together into one video. So I'm going to discuss the measures of variability today, and your objective is I can find how much variance is in a data set by finding the range, interquartile range, and mean absolute deviation. That word range should sound familiar because I already taught you that. And interquartile, that word quartile, should sound familiar from yesterday's box plot lesson. You guys know how to find the mean. That's another familiar word. That's when you find the average. Okay, and we'll be doing a lot of that today. So, first of all, the word variance means change in how much a data set is spread out. So if you're looking at your set of data, sometimes your numbers are very close to each other and sometimes they're spread out really far. And so we're talking about how spread out those numbers are. You guys know that to find the range, it's the difference between the greatest number and the smallest number. So you take your largest data or number in your data set and then subtract the smallest. Abigail, shh. Now the interquartile range is the difference between the upper quartile, which you did yesterday, and then you subtract the lower quartile. Same process, it's just the range versus the interquartile. Do some practice. First of all, remember this box plot picture from yesterday. So to find the range, you take this number, your whisker that's to the farthest right, and you subtract this number. You take greatest, and this is for the range, minus least. Okay? And that will give you the range. Now, if you have your interquartile range, you're going to take your upper quartile and subtract your lower quartile. I like to think of it, subtracting whiskers gives you the range, subtracting the box gives you the interquartile range. So you do the upper minus the lower equals the interquartile. Interquartile range. And we're going to do an example problem here just now. Okay, oops, that was the wrong button. Okay, there we go. So here's our example problem. You're going to use the range and interquartile range to compare the data sets. So this box plot shows the price in dollars of a handheld game player, maybe like a Nintendo DS or a Nintendo Switch, it doesn't say, at two different electronic stores. Maybe Radio Shack, maybe GameStop, doesn't tell us. Find the range and interquartile range for each data set. Okay, so that's what we want to do. Let's see, I can get my blue marker here. Whoa, I dropped my pen, sorry. We want to find the range and interquartile range for each data set. And then we want to compare the variability or the difference of the prices of the handheld game players at the two stores. So store A, here's your box and whisker plot. You're looking for the range. Now the range is, remember, the greatest number, subtract the smallest number. So for store A, we're going to take, is that 150? Yeah, 150. And then we're going to subtract, and that came from right here, and we're going to subtract 24. So 150 subtract 24 would give me 126. Now for the interquartile range, I'm going to subtract the box. So I've got 72 minus, now I'm not doing the number inside of the box. I'm not doing this number. Remember, that's our mean. I'm going to do the outside of the box, which is 48. Equals, I don't know what that is, hold on. Minus 48. Do some regrouping. Is 24. Okay, so that's my range and interquartile range for store A. Now for store B, it's the same process. I'm going to take my, let's switch colors here. I'll do red. I'm going to take my greatest and my least, 120 minus 30 equals, and that's 90. So you can see that it looks like there was a greater range in store A than there was in store B. And then I'm going to take my interquartile range. I have 100 minus 42 equals, that should be 58. Yeah, that's right. So you'll notice that our store A had a larger range, but our store B had a larger interquartile range. Okay, so that is showing that it looks like maybe there was an outlier at store A that put $150 when most of the places had it cheaper, and store B was pretty evenly spread out. It's your turn to try it. Sorry, Abigail's eating my counters for one of the little investigation things we're going to be doing here. Abigail, stop that. Okay, so you guys have a turn now. You're going to find the range and interquartile range of the data in this box plot. Now the only hard part is they didn't label those numbers for you, so you're going to have to kind of count on the number line. So find the range and the interquartile range. Go ahead and pause your video and try it on your own. Okay, while the video was paused, I went ahead and found what those numbers were. So for my range, it says I need to find the difference between the greatest and least values. So between 19 and 7. So 19 subtract 7 would give me 12. So the range is $12. And the interquartile range would be the numbers on the box. So it would be 15 minus 12, which would give me $3. Alright, and that's all the range problems I have. So if you have any questions, please make sure you ask, because there is a whole bunch of practice in lesson 13.4. I did go a little bit backwards. The mean absolute deviation is in 13.3 and 13.4. Range and interquartile range are just in 13.4. Okay? Alright, so mean absolute deviation. Now what this is, the word deviation here, it means to wander. So we're looking at our mean, and then how far away a number wanders away from it. So we're talking about distance. I'm going to call it MAD for mean absolute deviation. See how I did that? Mean absolute deviation gives me MAD, because it's a long name. So it tells us how far each number is from the mean. How far meaning distance. Okay? A small mean absolute deviation shows that the data set is very similar and very close together, while a large mean of absolute deviation means that the numbers are very spread out. So I'm going to show you a little investigation problem, and I think it will help me. So here's what we're going to do, and you can do this with me if you would like to. You do not have to, because I'm going to show you here on my board. So the number of magazine subscriptions sold by 2 teams of students for a drama club fundraiser are shown below. You guys have done fundraisers before. So you have one team and you have your other team. Now the mean number of subscriptions for each team is 4. So the average for each team was 4 magazines sold. So here's our numbers. Team A, it looks like somebody sold 3, 3, 4, 5, and 5. And team B, you had someone that sold 0 and someone that sold 8, but the mean is still going to be 4. So the first step is I'm going to make a dot plot for each data set using counters for the dots. And I'm going to draw a vertical line through the mean. And then I'm going to count to find the distance between each counter and the mean. And I'm going to write the distance underneath each counter. Okay. Let's see, I'm going to sit up here a little bit. Those are my husband's cool shoes. He's very proud of them. You can see them. They're LeBron shoes. Whoops. Anyway. Okay, sorry, I'm covering up the... Where's the camera in this? Alright, maybe. Okay, so Team A, here's the numbers that they sold. That they sold. And remember, Abigail, please stay out of the way. Here's my dot plot. And I have... My mean is 4, so I'm going to mark that here. Here's the mean. Okay? Now, Team A sold 3, so I'm going to make a little dot plot. This is so difficult to be able to see what I'm doing and hold this iPad at the same time. Okay. And someone else sold 3. Somebody sold 4. Somebody sold 5. And somebody sold 5. Today we're using Apple Jacks for counters, if you ever had them. They're not my favorite, but they're pretty good. Now, and here's Abigail. eating them. Sneaker. Now it told me after I put them on the dot plot that I needed to say how far away they were from the mean. So when I look at the mean, which is 4, there's one dot that is 0 spaces away. Okay? Now there's, when I have 2 counters on 3, so this counter is 1 space away from the mean, and this counter is 1 space away from the mean. Now this 5, this counter is 1 space away from the mean, and this counter is 1 space away from the mean. Now let me show you what Team B is going to look like, because it's going to be a little bit different. So here I have my second dot plot down here for Team B, and she's going to eat all of these counters before the night is up. Abigail, stop it. So we have 0, 1, 4, 7, and 8. Now remember, our mean is still 4. So I'm going to put a line here. And it told me to put the distance from each counter. So this one, that's actually 4, the distance is 0. But how far away is this 0 from 4? 1, 2, 3, 4 spaces. So this distance is 4. Now this 1 is 1, 2, 3 spaces away. So I'm going to put a 3 underneath it. See that? Over here, that's 7. 7 minus 4 gives us 3 spaces away. And 8 minus 4 gives me 4 spaces away. So we're looking again at the distance that we have from our mean. You'll see my pile is just about gone over here. So once I find the distance, I'm going to take this data set, and I'm going to look at Team A again. Oops. And I'm going to find the mean of the distances. So down here, I'm going to take my distances. I had 1 plus 1 plus 0 plus 1 plus 1 equals, and I'm dividing it by 5 because that's the total number I had. So 1 plus 1 is 2, plus 0 is 2, plus 1 is 3, plus 1 is 4. So I have 4/5. And then I'm going to take my B data set, and I'm going to take these numbers, the distance away from the mean. Okay? Abigail, you can't eat the ones on the board. Now, so this one's 4. I'm going to put it down here on my little fraction. Plus, I'm going to take this 3 plus 0 plus, this 7 had a 3. I'm putting it down here. Plus, there was a counter here until Abigail ate it, which would be 4. Now I'm going to add those numbers together. Focus in. Can it focus? Maybe. There it goes. 4 plus 3 is 7. 8, 9, 10, 14. So 14/5. 5 goes into 14. I'm just going to simplify here. Twice 4/5. So 2 4/5 is our answer. So remember, we had 4/5 for Team A, which means it is not spread out very much. Not very spread out. And Team B was 2 4/5, which means very spread out. And if you look at our dot plots, you'll notice that a little dog ate half of the counters. That was a bad dog, Abigail. But you notice, sorry, let me get my Apple Jacks again. We had enough Apple Jacks on here, Abigail, a little stinker. See how these are all clustered together, and this one is very spread out? That's because of those mean of deviation. This one was very close together, and this one was very spread out. Okay, hopefully that helps. You're going to see some example problems in just a second here, and see if it makes a little bit more sense. If not, please ask questions. Okay, so sorry about that really confusing investigation activity, but here, for those of you who like steps, here are the steps to find the mean of absolute deviation. First, you find the mean. Now, sometimes, like that problem, it told us the mean was 4. Unless the problem already told you, then you don't have to find it. But first, you might need to find the mean of your data set. Once you find the mean, you find the distance of each number from the mean. This is like a new set of data. Then, once you find the mean of the distance, then you find the mean of the distances by adding them up and dividing them by how many distances you had. And you simplify if needed. Remember, a small mean absolute deviation means that data is very close together. A large MAD means the data is very spread out. Make sure you write down those steps in your notebook so you can refer to them, especially if you get to use your notebook on your work check. Alright, so here's an example problem. This dot plot shows the age of gymnasts, people that do gymnastics, registered for the school team. The mean of the ages is 10. So here it gave us our mean. It says our mean is 10. We're going to find the mean absolute deviation of the data. So our step 1 is we need to able each dot with its distance from the mean. Remember, our mean is 10 right here. So let's start with all of these dots by the 10 because these are easy. They're 0. Because they are not at all far away from the mean because they are the mean. This 9 right here is 1 step away. And these 8s are 2 steps. 2 spaces away. There's no 11s. So our 12s are going to be 1, 2 steps away. And our 13 is 3 steps away. Okay? Because we're looking at where is that mean, which is 10, and we know that because it told us in the problem. Now, to find the mean of distances, we're going to take all of these distances. Now, remember, we're using these numbers up here, not the numbers down here. That would just give you the mean of 10. But you're looking for the mean up here. It's going to give you a pretty small number, actually. Okay, so 2 plus 2 plus 2 plus 2 plus 1 plus 0 plus 0 plus 0 plus 2 plus 2 plus 2 plus 3. Now, even though these zeros are not going to change the adding, it does change. We need to make sure we count them when we're using this number here. So, 1, 2, 3, 4, 5. I'm counting my zeros. 6, 7, 8, 9, 10, 11, 12. Looks like we have 12 numbers. Okay, so we're going to divide it by 12. And I'm going to add these up. Now, if these numbers get too big, you can use a calculator today, but I can do this in my head. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now I have 18 divided by 12. That will give me 1 with 6 twelfths left over, or 1 1/2. So the mean absolute deviation of the data is 1 1/2 years. So it looks like most numbers are between 1 1/2 years away from 10. So around 8 1/2 or 12 1/2 or 11 1/2. Okay? So that is how to find the mean absolute deviation of the years. Find your mean, find the distances, find the mean of the distances, and simplify. Let's let you try it. So here you're going to find the mean absolute deviation for both sets of data. You're going to explain which data set is more spread out. So you have the number of laps that Shauna swam on 5 different days. On Monday she swam 5, on Tuesday 6, on Wednesday 6, on Thursday 8, and on Friday 10. Your mean is 7. And then you're going to find the number of laps Lara swam on 5 different days. Monday 1 lap, that's not very many. Tuesday 3, Thursday 7, whatever day I'm on 11, and the last day 13. Sorry, I am really tired. It's like 2 in the morning. And then your mean is again 7. So go ahead and find the mean absolute deviation for each woman that swims, and then fill in the rest of this sentence. Pause your video and press play when you're done. Okay, so let's go ahead and I'm going to check this with you. Now, one mistake you might have made is you might have just put these numbers into this formula, and that would have given you a mean of 7. But that's not correct. Remember, you have to find How far away is 5 from 7? Well, the answer is 2. How far away is 6 from 7? The answer is 1. 6 from 7 is 1. How far away is 8 from 7? 1. How far away is 10 from 7? 3. Now I'm going to divide it by how many I had. 1, 2, 3, 4, 5. So I'm going to do some adding. 2 plus 1 is 3, plus 1 is 4, 5, 6, 7, 8. I have 8 fifths, which would give me 1 and 3 fifths. Then I'm going to do this one over here. I'm going to divide by 5. So I'm looking, how far away is 1 from 7? 6 places. How far away is 3 from 7? 4 places. And that, I'm just doing 7 minus 3. 7 is 0 spaces away from 7. 11 minus 7 is 4 spaces away. And 13 minus 7 is 6. Okay? We're dividing by 5. 6 plus 4 is 10. Plus 0. 4 plus 6 is 20. And 5 goes into 20, and that would give me 4. And this one was 1 and 3 fifths. So remember, the data set of Shauna or Lara is more spread out because the bigger our number is, the more spread out it is. And her data set is larger. That's how we knew it. So because that number was so much larger, 4 is so much bigger than 1 and 3 fifths, that's how we knew it was spread out more. But if you look at it, you can see from her data set, on one day she swam 1, and on another she swam 13. And Shauna's is pretty close together. It's not very spread out. Okay, here's your last problem. This is the one you need to check off with the teacher before you can move on. So I will not give you the answer here. It needs to be checked off with the teacher. I'm going to pause the video now. Actually, I'm going to stop the video, and you should pause it, and then you are all done. Thank you so much. Have a great day of learning.